Bismillahirrahmanirrahim. We are going to start question number 2 of exercise 2.4. This is the first part where in all of these parts we have to prove the left hand side equal to the right hand side. So here this is the left hand side. It is a determinant matrix and we have to equal it to minus 2 into x cube plus y cube. So first of all we are going to write the left hand side, which is x y x plus y x plus y and x plus y, x and y. Now first of all we can clearly see that the sum of all of these rows is equal. So we are going to add these columns into the column 1. So it is going to be c1 plus c2 plus c3. Whenever we write it this way, this means that that the sum of all of these columns will be written in the first one. Whatever is the first row or the first column, all of this expression will be performed in this first element. Okay, so let's do it now. It is equals to, now add up all of these columns, we get x plus y plus x plus y, then we have y plus x plus y plus x, and then x plus y plus x plus y. And then we are going to write the rest of the columns as it is: y, x plus y, x plus y, x and y. Now this is equals to x plus x is 2x, y plus y is 2y, and same goes for the rest of the rows as well. 2x plus 2y, and the rest of the columns will be written as it is. Okay, now let's scroll a bit downwards. Okay, now we can take 2x plus 2y common from this whole column. So we are going to get 2 into x plus y, and then we have 2 into x plus y is taken common, so we are left with 1, 1 and 1, and the rest of the columns are to be written as it is. Now we have to find the determinant, but to make the determinant easier to find, we can make these two as 0, and then we can use the column 1 to expand, and so it will be easier to expand. When the rest of the terms are 0, we only will have to expand 1. So we'll only have to find one minor matrix, and when we'll solve it, you can understand it better. Okay, so it is equals to 2 into x plus y. What are we going to do? We are going to make these two rows as the first elements of these two rows as 0. So for that we are going to subtract it from row 1. So what are we going to do is r2 minus r1 and r3 minus r1. Let's do it now. First row will be written as it is: 1 y and x plus y. This one is going to be 1 minus 1. Then we have x plus y minus y. And then r2 minus r1 is going to give us x minus y. Then again we have 1 minus 1. Then we have x minus y. And then we have y minus x minus y. Y minus x minus y. So what is cancelled? 1 minus 1, 1 minus 1. Then we have x minus x and y minus y. So 2 into x plus y into, now this is 1 0 0. Then we have y. Okay, these two are also cancelled. X and x minus y. Then we have x plus y minus y and minus x. Now we are going to expand it using column 1. Expand using column 1. Scroll, and we have, okay, it is equals to 2 into x plus y is to be written as it is, and then we are going to have 1, and its minor matrix is going to be, remove this row and this column, and we are left with x minus y and x minus x. Write it in the same order. Let's open up this minor matrix. 2 into x plus y into 1 into, okay, x into minus x gives us minus x square, then minus sign will remain as it is, then we have minus y, so it will become plus y, and then x minus y. 2 into x plus y into minus x square plus xy minus y square. Now we are going to take this negative sign as common. Minus 2 into x plus y into x square minus xy plus y square. Now we can use the formula over here. The formula is, let me change the color. Okay, a cube plus b cube equals to a plus b into a square minus ab plus b square. Now put a equals to x and b equals to y, and we get the formula over here. So we are going to fill it in the next step. So minus 2 into x cube plus y cube, and this is our right hand side. So this is our second part. First of all, let's open the brackets of the right hand side. So right hand side is a plus b plus c into a square plus b square plus c square, and it is equals to a into a square plus b square plus c square plus b into a square plus b square plus c square, and then plus c into a square plus b square plus c square. A cube plus ab square plus ac square plus a square b plus b cube plus bc square plus a square c plus b square c plus c cube. So this is our right hand side. Now we have to solve the left hand side. Let's write it over here. Left hand side is a plus c and a minus b minus c, b and a plus b plus c, c minus a, c. Let's expand it using row 1. Expand using row 1. So it is equals to a into its minor matrix is going to be b, a plus b, c minus a and c. Then we have minus, the second element is b minus c. Its minor matrix is going to be a plus c, a minus b, c minus a and c. Then plus, the third element is b plus c, and its minor matrix is going to be a plus c, a minus b, b and a plus b. Now we are going to solve these determinant matrices. So a into bc minus c minus a into a plus b, then minus into b minus c. Okay, let's change this negative sign, plus make it positive, and then multiply this negative sign with these two terms. So we get c minus b into, let's multiply these two elements, c into a plus c minus c minus a, c minus a into a minus b. Then the third element is plus b plus c into a plus c into a plus b, and then minus sign, then b into a minus b. It is equal to a into b minus c, bc minus, then we are going to multiply these two brackets together. So we get ac plus bc minus a square minus ab. Then oops, we have drawn the wrong brackets. Okay, this is minus a square minus ab. Okay, then we have plus c minus b into ac plus c square minus, then again bracket c multiplied by this bracket, we get ac minus bc. Then we are going to multiply minus a with this bracket, so we get minus a square plus ab plus b plus c into, now let's multiply these two brackets, so we get a square plus ab plus ac plus bc, then minus ab plus b square. Okay, a into bc minus ac minus bc plus a square plus ab plus c minus b into ac plus c square minus ac plus bc plus a square minus ab plus b plus c into a square plus ab plus ac plus bc minus ab plus b square. Now let's see what can be cancelled. bc minus bc, then we have ac minus ac, then we have ab minus ab. Now let's solve it. A multiplied with this bracket, we get minus a square c plus a cube plus a square b. Now c multiplied with this bracket, we get plus c cube plus bc square plus a square c minus abc. Now b multiplied with this entire bracket, we get minus bc square minus b square c minus a square b plus a b square, right? Yeah. Now we are going to multiply b with this entire bracket, so we get plus a square b plus abc plus b square c plus b cube. Now c multiplied with this bracket, we get plus a square c plus ac square plus bc square plus b square c. Now let's see what can be cancelled. So minus abc plus abc, then we have minus b square c. Let's find b square c. Yes. Then we have minus bc square plus bc square minus a square b plus a square b. Then we have minus a square c plus a square c. Okay. Now let's write down the leftover terms. A cube plus c cube plus bc square plus a square c plus ab square plus a square b plus b cube plus a square c plus b square c, right? Now let's see if we are done with all of these terms. Let's minimize it a bit. Okay, now we are going to compare the terms. A cube ab square, where is ab square, ac square, then we have a square c, we have done something wrong, a square c, okay, yep, here is the mistake, here it is written. Okay, let's compare the rest of the terms first. A square b, b cube, and we have b cube, then bc square, where is bc square, then we have a square c, b square c, and then c cube, and then c cube. Yep. Okay, here we can see that this a square c is to be cancelled with this a square c. So this a square c is practically absent. Let's remove it from here. There it goes. Yes. And so this a square c and this a square c are here. So this side and this side are proved to be equal, and we have proved the second part as well. Now let's move to the third one. Here we go with the third part. Let's write the left hand side, which is na1 plus b1, then nb1 plus c1, and nc1 plus a1. Then we have na2 plus b2, nb2 plus c2, and nc2 plus a2. And the third column is na3 plus b3, nb3 plus c3, and nc3 plus a3. Okay. To solve this part, we are going to separate the two columns, the first column and the second column, into separate determinant matrices. So let's write it as, okay, so the first column over here will be na1, nb1, and nc1. Then the first column of this one will be written over here, so we are going to write it as na2, nb2, and nc2. then NA3, NB3, and then C3. Then plus, and the rest of the terms are going to be written over here. These three columns will be are going to be written over here with the same order as well. So we are going to write it as B1, C1, A1, B2, C2, A2, and B3, C3, and A3. Now we are going to take n common from all of these terms. So we are going to write it as n into from the first row, then n from the second row, and then n from the third row. And then after taking n common, we are going to write it as A1, B1, C1, A2, B2, and C2, A3, B3, and C3, plus this matrix will be written as it is. Okay, now as we have to make this determinant matrix similar to this one, so we are going to shift rows. Now the rule is that when we have to shift the rows, we'll have to write a negative sign in front of the matrix. So here we are going to write a negative sign instead of the positive one, and we are going to bring this row over here. So definitely this row will come over here. So we are going to write it as A1, A2, A3. This row will be written undisturbed, C2, C3, and then B1, B2, and B3. It is equals to n cube into the same determinant matrix A1, B1, C1, A2, B2, C2, and A3, B3, and C3. Then this negative sign will be changed to positive because now we have to swap these two rows. So let's write it as A1, A2, A3. These two will be swapped. So we are going to have B1, B2, B3, and then C1, C2, C3. It is equals to, now let's take this determinant matrix as common over here. So A1, A2, A3, B1, B2, and B3, C1, C2, and C3. And then we have n cube plus 1, and which is our right hand side, hence proved. So in the fourth part, we are going to use the same concept as the previous third part. So we are going to first of all separate these two columns and then make them separate in determinant matrices. So here we go, left hand side is x, y, z, x square, y square, z square, and 1 plus ax cube, 1 plus ay cube, and 1 plus az cube. Now let's solve it. It is equals to, so let's separate it, x, y, z, x square, y square, z square, and we are left with 1, 1, 1 in this determinant matrix, and the other determinant matrix will have ax cube, ay cube, and az cube. Now let's take a common from this column. So we have to write this determinant matrix the same. Now as we can easily see that we can take x common from the first row, y from the second row, and z from the third row. So we are going to take these as common. So x, x square, and 1, y, y square, and 1, z, z square, and 1, plus a, x, y, z, and 2. Okay, x is taken common, so 1, x, and x square. Now y is taken common from this row, so we are left with 1, y, and y square. Z is taken common from this row, so we are left with 1, z, and z square. Now as we can see that we have to make these two similar. So 1 is the last column, so we have to bring it to the end. So it is going to be x, y, z, x square, y square, z square, 1, 1, 1. And then we have to change the two columns, so we are going to write a negative sign over here, ax, y, z, and then x square, y square, z square, x, y, z, and 1, 1, and 1. Now again we'll have to shift these two columns too for the same reason. So x, y, z, x square, y square, z square, 1, 1, and 1. Then now this negative sign will be changed to positive because we again have to um, do a swap. And then we have x, y, z, x squared, y squared, z squared, and 1, 1, and 1. Now let's take this determinant matrix as common. So we are going to write it over here. X, y, z, x squared, y squared, z squared, 1, 1, and 1. And 1 plus a, x, y, z. Now let's make these two 0 so that we can find its determinant easily. So we what are we going to do? R2 minus R1 and R3 minus R1. Okay, we are going to write this bracket in the beginning. 1 plus a, x, y, z into, we have x, we don't have to do any change on in the first row, so x, x square, and 1 will remain as it is. The second row will become y minus x because row 2 minus row 1, so y minus x, y square minus x square, and 1 minus 1. Now we have z minus x, z square minus x square, oops, yeah, z minus x, z square minus x square, and 1 minus 1. Now let's solve it. 1 plus a, x, y, z, x, y minus x, and z minus x, x square. Now this is a square minus b square. What is the formula? Formula is, I'm going to write it over here, a square minus b square equals a minus b into a plus b. So let's write it over here, y minus x and y plus x. So y minus x into y plus x, and then we have again z minus x into z plus x, 1, 0, and 0. Now we are going to take y minus x common from this row and z minus x common from this row. So first of all, write it as it is, 1 plus a, x, y, z into, taking y minus x common from the second row and z minus x common from the third row, and we are left with x, 1, 1. Then there is x squared, y plus x, and z plus x, and then we have 1, 0, 0. Now let's expand it using column 3 because there are maximum zeros in column 3. Now we are going to expand it. We are going to write these as it is, 1 plus a, x, y, z into y minus x into z minus x. And now we are going to expand it. 1 into its minor matrix is going to be remove this row and this column. So we are left with 1, 1, y plus x, and z plus x. And write it in the same order. 1, 1, y plus x, and z plus x is equals to 1 plus a, x, y, z into y minus x into z minus x into, now 1 into z plus x is z plus x, negative sign, and then 1 into y plus x gives us y plus x. It is equals to 1 plus a, x, y, z into y minus x into z minus x into z plus x minus y minus x. X and minus x are cancelled. And we are left with 1 plus a, x, y, z into y minus x into z minus x into z minus y. Now to make it similar to the question, to the given question where there is written x minus y and y minus z. And here we have y minus x and z minus y. So we are going to take negative common from this one and negative common from this one. So when two negatives will multiply, it will again become positive. So we are not going to write it. So 1 plus a, x, y, z into y minus x will change into x minus y. Z minus y will change into y minus z, and then z minus 6 will be written as it is, and this is your right hand side proved. Thank you.